Hello, my name is KV Muralidhar Sharma, a research scholar in educational technology as applied to engineering thermodynamics at VTU. Uh, Last class we talked about different types of thermodynamic systems. This class we talk about the role of boundaries in continuation of the last class. In the last assessment, in the last assignment called as TPS, we have identified some systems as we have identified some engineering systems. We we identify open system, closed system, and isolated system amongst them. In this class, in continuation with that, one aspect which is not heeded to, that's the concept of the boundary we'll talk about. Now, to put it simple, we will talk about the importance of the boundary in defining the thermodynamic system. The concept of the boundary was left out in the previous concept. The objective, the takeaway for the students, there are two takeaways from the students. One is in identifying the importance of the boundary in specifying the system as closed or open, and how it's up to the imagination, how it is up to the concept of an individual in identifying the boundary, and how a boundary can be transformed from open system to closed system. Let's recollect when we were discussing the previous concept. We didn't much talk about the boundary, systems, and surroundings. Though boundary is an important part, for the sake of simplicity, we have just neglected, or we have just postponed that, and that we are going to talk. Let's recollect, we had a three-stage approach wherein we have identified mass as one parameter, and work and heat, the two types of energies, as the three parameters in identifying open, closed, and isolated system. Through a matrix, we have understood different types of system. Now coming to the topic. Now the question is, if we pose a simple question, is a four-stroke engine an open system or a closed system? You can just think about it. You can just try to answer yourself. Of course, we have collected. I collected a similar survey in one of my previous classes of 56 students. Can you guess what could be the answer? Is a four-stroke engine an open system or a closed system? 30 students answered it as an open system, and rest of the students answered it as a closed system. Now the question is, who are right? The 30 students are right, or rest of the students who are right? The simple answer is both of them are correct. Now the question is how there can be two answers to the same question. That is where the concept of boundaries comes into picture. A four-stroke engine can either be an open system or a closed system. If we consider a simple piston cylinder arrangement, during two strokes, namely, if we recollect our elemental study of IC engine, if we recollect the four process of which two, expansion and compression, wherein two valves are closed, the system works as a closed system because there is no mass flow in and out. If you provide a small aperture on either side, there is a mass flow, and the same system is transformed into a closed system. So this is the concept we are trying to learn. So you can take these two openings, opening in and opening two, as inlet wall and the outlet wall in a practical case. As a theoretical case, we can take an mass in and mass out. So the same system, namely an IC engine, a piston cylinder arrangement, to put it simple, can either be an open system or a closed system. And precisely during a four-stroke working, during a suction stroke, it works as an open system, because during a suction stroke, though one valve is closed, the suction valve is open, there is a mass flow into the system, and the system works as a closed system. During the next two strokes, namely the compression and expansion stroke, the system works as a closed system, and the last stroke, namely the exhaust stroke, the inlet valve will be closed and exhaust valve will be open. There is a mass flow across the boundary and resulting the system as a closed system. We can have a couple of examples more. Here is a simple example where an open system, a closed system. If you arrest the mass flow, this becomes a closed system. If you arrest the heat flow, the energy flow through an insulation, this becomes a closed system. You can take few more examples here. Fine. What's the takeaway? Now we'll have a small reflection quiz. A frying pan on the gas stove is a dash system. The question is open to all of you. You can just take a minute to think over it. A frying pan on a gas stove is a dash system. An open system. The options, there are 4 options. An open system, a closed system. Option C can either be a open or close, A or B depending upon the boundary condition. D, none of the above. The answer remains correct. Answer remains C. It can either be an open system or closed system depending upon the boundary conditions. That is the purpose of this video. You can please take up two exercises, 2 assignments. So you can have an illustration. You can take any illustration of your own demonstrating how an open system can be transformed into a closed one. Indicate in both the cases the boundaries. You can take the second question, a 4-stroke IC engine, an open system or a closed system, and how these boundary conditions differ during different strokes of operations. Both these assignments you can submit before the commencement of the next session. Thank you.